Suppose the question says that warp and weft yarn with a diameter of 0.4 mm and 0.6 mm are used to produce a plain woven fabric with end and peak spacing as 0.25, peak spacing as zero point 0.8 and 1.2 mm. Assuming the degree of flattening in warp and weft to be zero point 0.8, the approximate fabric cover would be. So how we will calculate the fabric cover? D1 is given to be 0.4 mm. Here what is given? Degree of flattening. Degree of flattening means basically it is a kind of flattening. It is a ratio. What is the ratio? If degree of flattening is given, means the fabric is flattened in this way. So if there is any degree of flattening is given, then the net diameter is during the flattening, the diameter is reduced. If you can see here, the fabric is flattened. There are so many factors that are involved due to the for the flattening of the fabric. So if the degree of flattening is given, we have to divide. The net diameter is d dash is equal to d upon e, because if you will divide, then the actual diameter will be somewhat higher than the original diameter. After flattening, the diameter is reduced, and we have to take the original diameter of the fabric. So in whatever, in the case where degree of flattening is given, we have to divide it by E. E is here degree of flattening. So here what is given as 0.4 upon thick spacing is given, and has to be this. D1 as this, D2 as 0.6 mm, and end spacing. Spacing is basically spacing, EPI, ends per inch, ends picks per inch. What we have read. So here spacing is given. So you know the spacing D by E. So cover, we have learned the formula that DN spacing is represented by P, and it n is equal to 1 upon p. We have already read these things. So the cover is d upon p. Formula is d upon p. So d upon p is how much? 0.8. C2 is 0.6 upon 1.2. Whatever the thing will come, that will also be divided by degree of flattening. Degree of flattening is how much? 0.8. So we will also divide the answer by 0.8 into 0.8, divide by 0.8, sorry, divide by 0.8, divide by 0.8. So if you will calculate, then what it will come out to be 0.625. And when you will divide this also, then it will also come out to be 0.625. C1 is equal to 0.625, C2 is equal to 0.625. The cover, you know, the formula of cover is C is equal to C1 plus C2 minus C1 C2. So we can calculate, since C1 and C2 both are same, C plus C minus C2 CC. Since C1 is equal to C2, we can say it to be C. Then it will come out to be C2C minus C square. This is C, the C. C plus C is 2C. C into C is C square. We will calculate 2 into 0.625 minus 0.625 the whole square. C is equal to 0.86. This is the approximate fabric cover. And suppose they ask about the fabric cover factor, then C is the fabric cover factor. Irrespective, C1 and C2 are warp cover factor and weft cover factor. and it is the fabric cover factor that will include both the warp and the weft. So if I talk about cover factor, this is cover, and cover factor is K, that is equivalent to 28 times C. So how you will calculate it? If you will calculate that, 28 into C is 0.86. If you will calculate this, then it will come out to be approximately equal to 24. This is what the cover factor is. So this is basically the answer. In this way, these questions are designed and framed. I think these things are clear. So we have finished this part. Now we will proceed ahead with the fabric geometry concepts. How we will do the fabric geometry.